This is a video about arithmetic sequences. That's a word that looks like arithmetic, but when we put it in front of sequence, we pronounce it arithmetic. 9, 13, 17, 21, and then the ... indicates that this list goes on forever, is an example of a sequence. A sequence is just a list of numbers that forms a pattern. And again, this pattern will keep going with the ... The name for each number in the sequence is called a term. So 9 is a term, 13 is a term, 17 is a term, 21 is a term. Now, I said that a sequence is a list of numbers that forms a pattern. So let's see if we can find the pattern in this one. What I'm seeing is that when I go from the first term to the second term, 9 to 13, what I'm doing is I'm adding 4. And then when I go from 13 to 17, it's the same thing, I'm adding 4. 17 to 21, same thing again, I'm adding 4. So the pattern in this sequence is that you add 4 every time. And because we're adding 4, that's why this is called an arithmetic sequence, because you add, or we'll see somewhere you subtract, to get to the next term. So for a definition of arithmetic sequence, we have a sequence where you add the same thing to each term to find the next one. So in this case, we're adding 4 to each term to find the next one. That amount that you add to each term to find the next one is called the common difference. And so we're going to usually call the common difference D. So in this sequence, we would say that D equals 4 because we're adding 4 to each term. So if you know the first terms and the common difference, it's really easy to find other terms in the sequence. If I wanted to find the next 3 terms in this sequence, I would just keep adding 4 onto the end. So my last term so far is 21, so if I add 4 to that, I get 25. And then if I add 4 to that, I get 29. And if I add 4 to that, I get 33. So now I'd like you to try something. In your notes, make up your own arithmetic sequence. Give it at least 4 terms and then put the ... on the end to show that it keeps on going. Then say what your common difference is, and then say what the next 3 terms after your 4 would be, so you'd have 7 total. Pause the video now, do this in your notes, and then continue. The last thing that we're going to do is called finding the nth term of an arithmetic sequence. So when you would want to do this is in a scenario like this. You know that the first term of an arithmetic sequence with a common difference of a half is 5. And what you want to do is find the 23rd term. You're going to think, what do you do? So what you could do is you could say, well, I know that my first term is 5. And to get from that first term to the second term, what you have to do is add a half. So you could say, well, I'm going to jump over, add a half, and then what I'm left with is 5.5. And then to get to the next one, you would add half again and get 6, and you could keep doing this until you get to the 23rd term. But that would take an awfully long time. And it would take that long because you have to add a half, not just once or twice, but you have to do it a total of 22 times. So a shortcut that you could take, and this is the way that people typically do it, is you could just take that first term 5 and you could add a half times 22, because instead of adding a half 22 single times, you could just add a half times 22. So that's easy. You can do a half times 22, which is 11, and get 16. So 16 is your 23rd term. And you would have gotten the same thing if you had sat and added a half 22 times, but this is way easier. There's actually a little formula you can use for finding the nth term, and we're going to talk about that right now. So when I talk about the nth term, what I really just mean is any term of a sequence. I could ask you to find the 56th term, or the 117th term, or the 256th term. This is just a way to find any term easily. The example that we saw, what you need are 3 things. you need to know what the first term is. So in the last example, we knew that the first term was 5. You need to know what the common difference is. So in the last one, we knew that the common difference was a half. And finally, you need to know which term you want to find, because if you don't know what you want to find, how can you do the problem? So we're going to call the first term of an arithmetic sequence a sub 1. So a is a term, and 1 is the first one. We'll call the common difference d, like we've been doing. And then the term that we want to find is going to be a sub n. So n is going to be whatever we say, 11 or 23 or 117 or 56 or whatever. And so our formula is going to be that a sub n is always going to be the first term, a sub 1. And then we're going to add n minus 1 times the difference. So just like in the last problem, we said that we wanted the 23rd term, so we added a half 22 times. It was 1 less. That's what we're doing here. If we want the nth term, we're going to add that difference 1 less time. So write down this formula, and then we're going to do a couple of examples using it. It's going to be really easy once you see what's going on. So here are our examples. The first one is find a sub 17 if a sub 1 is 7 and the common difference is negative 3. So a sub 17 means the 17th term. So to do that, we're going to say that a sub 17 equals the first term, a sub 1, plus negative 3 times some number. So if we want the 17th term, we need to add that difference 16 times. So what we're going to do is we're going to do 7, and then 16 times negative 3 is negative 48. And when you add those together, you get negative 41. So what we're saying here is that the 17th term in a sequence where the first term is 7 and you're subtracting 3 every time is negative 41. And that kind of makes sense, because if you're starting out at 7 and you keep subtracting 3 a bunch of times, you get down into the negatives. So in number 2, we want to find the 20th term of the sequence negative 30, negative 22, negative 14, negative 6, etc. So when we see the 20th term, that means that we're finding a sub 20. And if the sequence starts with negative 30, that means that negative 30 is a sub 1. And what we don't know is the common difference, but we can figure it out. When you go from negative 30 to negative 22, you add 8. When you go from negative 22 to negative 14, you add 8. Same thing going to negative 6. So that means that our common difference is 8, because we're adding 8, so it's a positive 8. So that means that to find a sub 20, our first term, which is negative 30, and we're going to add that common difference of 8, and we're going to add it 19 times, because if we want to get to the 20th term, we need to add 1 less than that. So we're going to add 19 times 8, so that's a lot. So 19 times 8 is 152, and then if you add 30, you get 122. So what this is saying is that the 20th term of this sequence that starts out in the negatives and then you add 8 every time is 122. And that makes sense. And that's all you need to know about arithmetic sequences.